Okay, we're going to start off just remembering how to solve equations that have second degree terms in them, or squares. So here's one, x squared equals 25. Now the simplest way to do this is to just say, well, here's an x and it's all by itself, but the only problem is that someone has squared it. So the opposite of that is taking the square root. So we take the square root of x squared, and then we take the square root of the other side, and we get the square root of x squared is x, and the square root of 25 is 5. But the problem with this is that if we look back and we think about what numbers we could square so that they equal to make 25, there's 5 times 5, that would make 25, but there is also minus 5 times minus 5. So when we do this process, we say what squares to make 25, we have to remember there's two numbers that will do that, plus or minus the square root of 25. So if we want to, instead of writing these two solutions, we can just write 1 plus or minus 5. So whenever we have a statement that looks like x squared equals 25, it leads us to basically either x equals 5 or x equals minus 5. And this is kind of like a two-way thing. So if the square of something is 25, then either x was 5 or minus 5, and if x is 5 or minus 5, then its square is going to be 25. So here we have a statement that is reversible, so we don't have any problems with finding these solutions. Here's another example quickly. Here, instead of just taking the square root, we're going to use the principle of zeros. So I'm going to add 2 to both sides to get a 0 on one side of my equation, which is totally reversible because if I want to go back, I can just subtract 2 from both sides. Now here I'm just going to rewrite this, x plus 2, x plus 1. That's factoring it, which is just really kind of saying that if we distribute this bracket over that bracket, we'll get this thing back. So nothing's really going on here except I'm using an identity to rewrite this side of the equation. And then from here, I use the logic that if I'm going to multiply two things together to get 0, then one of them or the other is going to have to be 0. And if either of these numbers is 0, when I go 0 times something else, I'm going to get 0. So this is a back and forth statement here using the principle of zeros. Here I can again subtract 2 from both sides, which is reversible, and here I can subtract 1 from both sides, which is also reversible. So long as my algebra is correct in this one and this one, I don't need to check my solution.